So now let's talk about the differentiated services. Let's discuss differentiated services. And in differentiated services, we have different types of per hop behaviors that we'll discuss in a minute. Like we have expedited forwarding, or we have assured forwarding per hop behavior that we'll discuss in detail. Differentiated services allocates resources to a small number of classes or traffic. Right? So instead of dealing with individual flow, so traffic is divided into classes. So traffic is divided into different classes rather than individual flows, right? So this means rather than using resource reservation protocol to tell routers that some flow is sending premium packets, it would be much easier if the packets could just identify themselves to the router when they arrive. So this will make the job of the router much easier. So rather than using RSVP, resource reservation protocol, the packet identifies itself to the router. The packet identifies itself to the router. So a packet identifies itself to a router. This is done by using a bit in the packet header. So this is done by using a bit in the packet header. Packet header. So if a bit is set, this means it's a premium packet. This means it's a premium packet. And if bit is 0, this means it's a best effort delivery. So if a bit is not set or is 0, so this means it's just best effort delivery. Okay, so the next question is, in fact, we have two questions to answer here. Number one, who sets the premium bit and under what circumstances? Second, what does a router do differently when it sees a packet with the bit set? So there are two questions to discuss here. Number one, who sets the premium bit? And under what conditions or circumstances? Number two, question number two is, what does the router do differently when it sees the packet with the bit set. So what does a router do differently when it sees packet with the bit set? Right, so the answer to the first question is that probably the service provider can identify that a specific interface of a router is dealing with the premium packet delivery or premium services. And a customer and a user requiring a premium services can pay additional for this purpose. But in order to answer the second question about the behavior of the router, IETF have standardized a set of router behaviors to be applied to marked packets. So here we have variety of router behaviors. So here we have variety of router behaviors defined by Internet Engineering Task Force. As Internet Engineering Task Force have standardized a set of router behavior to be applied to marked packets. Right. For example, this includes these behaviors are called per hop behavior or per hop behaviors. Per hop behavior indicates the behavior of individual router rather than end-to-end service. So per hop behavior indicates the behavior of individual router rather than end-to-end service. There are more than one new behavior, there is a need to have more than one bit in the packet header. So this means we have to modify the type of service field. So since there are more than one new behavior, there is a need have more than one bit in the packet header. This means the type of service field has to be redefined. Is redefined. And how it is redefined? Now, 6 bits of this byte have been allocated for differentiated code point. The remaining 2 bits are used by explicit congestion notification. So how we have redefined the type of service feed? By assigning 6, or allocating 6 bits. So 6 bits of this byte have been allocated for differentiated services or DiffServ code point. D is CP. And remaining 2 bits are used by explicit congestion notification. Right, so let's talk about the different per hop behavior or router behavior. The first type of per hop behavior is called expedited forwarding. So let's talk about the expedited forwarding. PF per hop behavior. All right, so in expedited per hop behavior, packets are marked for expedited forwarding and should be forwarded by the routers with minimal delay and loss. So a packet or packets marked for expedited forwarding should be forwarded by the router with minimal delay and loss. All right, so what do you think, what are the possible implementation strategies to achieve this? How a router will be sending or forwarding the packets marked expedited forwarding with minimal delay and loss. So what do you think? What are the implementation strategies? What are the implementation strategies? So what a router does is it gives expedited forwarding packets strict priority over all the other packets. So this means routers give expedited forwarding packets strict priority over all the other packets. For this, routers perform weighted fair queuing. Weighted fair queuing. weighted fair queuing between expedited forwarding packets and other packets and other packets. Right. So let's talk about the second powerhouse behavior, the assured forwarding. Assured forwarding per hop behavior. Right. So the assured forwarding per hop behavior has its root in random early detection in and out or weighted random early detection. So the assured forwarding makes use of as its roots in random early detection that we have covered in the previous lecture with in and out or weighted random early detection. So this concludes our today's lecture. So in today's lecture, we talked about quality of services. We established a case that we need to have new service model that can provide services or fulfill the requirements of real-time applications in addition to traditional end-to-end best effort delivery based applications. And then we try to identify the quality of service approaches providing quality of service support. Then we try to establish a taxonomy of real-time applications. And after defining the taxonomy of real-time applications, we discussed both approaches, the fine-grained approach and coarse-grained approach, means integrated services and differentiated services. Dear students, thank you very much. Allah Hafiz.